Alrighty. Can folks hear me? Hopefully that's a yes.
Yes,
Please, okay, perfect. Alrighty, I'm gonna get started. Welcome everybody. My name is Manasi Vartak. I am the founder and CEO of Verta Inc. I'll talk more about myself and Verta in just a moment, but today we're gonna be talking about the whole wave that is building around MLOps or machine learning operations, talking about what it is, why do you need it, and where do you begin, depending on the type of company you're at, the research group, etc. So let me start off with a bit about me and level set. So I have a technical background. I did my PhD in computer science at MIT, and my thesis work was on model management and diagnosis. So I built a open source project called ModelDB. It is a experiment management system. It helps you track all of the work as you're doing it, build beautiful charts based on it, and also help you take your models to production at a later stage. And on the other hand, I've done hands-on data science and ML at Twitter, Google, and Facebook, so can speak to how I've seen MLOps work in the industry as well. So that's a bit about me. The company I founded is called Verta. We provide a machine learning platform that is focused on operations, which means taking the models that have been built by the data science team, productionizing them, packaging them, and running them at scale. And I will show a few screens around the demo towards the end for folks who are interested. All right. So let's start off with why MLOps, and that's machine learning operations. Most people here, you're at ODSC because you've been doing data science in some form of or another. And the big change that we've seen in this space over the last 5 years is that models have become easy to build because of great libraries such as fast.ai, huggingface, scikit-learn has way better tooling, etc., and then similar libraries on the R side as well. Where we've seen repeated challenges are things like there are a lot of different frameworks and languages that a team needs to work with, whether it's TensorFlow, PyTorch, Onyx, if they're in Scala, R, etc. And there are a lot of platforms that you might be building your models on. And so when you think about moving your models from the data science team has built a particular model to I want to run a particular product using that model, the dynamic changes completely. To dig a bit deeper into that, the difference comes down to you can build a model in your Jupyter notebook, you can serialize it, you can pickle it. But once you want that model to actually serve recommendations, say on an Amazon.com, or you want it to be embedded in an Alexa device, or you want it to do fraud detection, the typical use case, it needs to go through a series of steps. Typically, that is do testing, submit your code into a Git repo, do packaging, integrate into CI and CD, make sure that the model scales, make sure that it's working as expected. And so what we find is that there is a host of steps that need to happen once a model has been trained, and different teams using different tools make this process very hard to govern and manage. In addition, typically the data science team is not well equipped to run models in production because that's not what they were hired to do. They were hired to build the best models that they could, not to keep a service running 24/7, which is what intelligent products demand. And we've seen this over and over again. If you're at a large organization, this means that your IT team is getting really freaked out every time the data science team releases a new model and it's using a new Python library that might have some sort of security restrictions that they're not aware of. So that's the second challenge that we've seen over and over again. And usually because data science is performed in a very ad hoc manner, there's a lot of models that are being used across the organization, and there is no control or visibility into where the models are running or how they're running. So as we transition from taking ML that works in research to building intelligent products around it, there are a host of issues such as these that come up. And I would be happy to talk during the Q&A about specific instances where we've run into this and so on. So that's the state of commercial AI and ML. And that really tees up the discussion around MLOps, because the challenges we're seeing in machine learning are not super unique to machine learning. There has been a big wave, which was a DevOps wave about, let's call it 15 years ago, where we developed a very robust stack to deliver software products faster and more reliably. And the typical way to think about this process is via this infinite loop, let's call it, where we have development on the left side and we have operations or production on the right side. And in order for a company like Facebook or Twitter to release their applications daily or hourly, what they have is a very tightly integrated set of tools that go from planning, it's like what work do I want to do, to creation. This is your IDEs, it's also your version control systems, to testing, that's the CI, to the packaging here, maybe it's Docker, maybe something else on Artifactory, to releasing these models, or sorry, releasing these applications into your product. That's where Jenkins comes in, GitLab comes in. Configuration management, configuring your infrastructure, configuring your services, then monitoring them so that they work at scale and they respect the SLAs that you've set. And then you find issues and you go back to planning. The key point I want to drive home here is that for DevOps, we've built this very rich stack that takes our software products from the development to operations and keeps this flywheel going. For machine learning, however, we don't have this stack. And that's what machine learning operations is at a high level all about. We want to deliver machine learning models faster and more reliably. We want to be able to build those models over on this left side. We want to test them. We want to then package them, put them, integrate them into our products and keep operating them, making sure they work as expected, and you keep going through the loop. So at a high level, that's what MLOps is. MLOps is not necessarily a set of tools. It is more of a discipline that you instill into the organization. That discipline is supported by tools that are currently being developed in the market. So that's MLOps that's a quick intro to MLOps. I'll now transition into what is the state of the world for machine learning operations. What are gaps and where do you begin if you are a machine learning team that wants to put more models into prod? So state of the world today really reflects what I mentioned early on, which is we've gotten pretty good at building models. We have Jupyter notebooks, which I love. We have great libraries, huggingface, fast.ai, PyTorch, TensorFlow, all of that. We have good planning tools. I think we're getting better at testing. I put explanations here to verify that our models are working as expected. So basic cross-validation, things like Lyman Shapley. If you're in the field, that's typically what you are doing in order to verify and validate that your ML models work as expected. The biggest gap that we see over and over again is on this side. I have a model, my data science team has worked very hard to get it there. How do I then integrate it into a product and keep it going? So that's what I'll focus on next and give you some hints on how does one get started in building out a MLOps toolchain. I'll begin with open source, and then I will, at the very end, also highlight what we do at Verta and give a sense of what an enterprise MLOps platform can get you. Okay, so suppose you're like, okay, I get it now. This discipline is going to help me build more intelligent products. Where do you begin? Now, if you're a small company or you're just one person who wants to mess around with machine learning operations, you can get started with open source. And I gave a talk in 2020 that I've listed here, which is Robust MLOps with Open Source. It walks through a full tutorial, takes about 45 minutes to build a bare bones pipeline. using the tools that are listed, and I'll go through them. So if you want to do machine learning operations, there are a few different things that you require. One is you want to have a version control system for your models themselves. You're probably using Git for your code. ModelDB, which I referenced earlier, we built it as an open source system that you can use to version and manage your models. So you can start there. That helps you keep track of everything that you have built so far and make it easier to hand it off to others. Once you have a versioning system in place, then you can move on to packaging. Typically, this is done via Docker. So you can build a pretty simple Flask-based web application that is going to serve your models. And all of the code is in this link, which is why I'm not going through it in a great amount of detail. Please feel free to check that one out there. Once you can Dockerize your models and you can package them into a web server, then you move on to how do I release this model into production. This is typically done via a system like Jenkins. It is a way to automate your build and release pipelines. So you can define a step in Jenkins or Jenkins pipeline that grabs a model from ModelDB. It's going to add your web server to it. It's going to Dockerize it, and then it is going to release it into, say, a Kubernetes cluster. If you're only running your model locally, then you can make do with just a Docker container. But if you're actually doing MLOps, you're going to be running it on a system like Kubernetes. There are other ways to deploy your models that involve, say, a Spark cluster or integration with Kafka that I'm happy to talk about as well. But typically, this is going to be your Kubernetes cluster. Once you have your model running, the next part of the process is actually monitor it and make sure that it's working as expected. So this is where you would look at the latency of your models, the throughput, also look at data drift, and make sure that your new data that you're seeing is actually similar to the data that you saw before. So all of this pipeline is a working version of the pipeline is linked via that blog post. I'm happy to answer questions during the Q&A about any details that you might come into, that you might have questions about there. But that's a quick view of what you can do to get started if you're doing MLOps at a small company, or if you're just an individual, kind of N of one, and you're trying to get started. All right, if you are a bona fide ML company, and I think we're seeing more and more of these come up, there are a few drawbacks of open source that you should be aware of. They're not unsurmountable, but things that you will run into. The first one is production support SLAs. So when you're running an intelligent application, you want to make sure that the application runs 24/7. It's not something you can run on the weekend and call it a day. That's where making sure that your requests are served within 100 milliseconds or your system is always highly available becomes crucial. The scaling is also very important. We work with teams who serve millions of requests across the globe per day, and that's where scale matters, because you can get bursts of a lot of requests and then very few requests. So your system has to be able to scale to that. User management is this funny thing that you don't think about until you're working on a team, and particularly if you're a manager who is listening in. What do you do when someone on your team leaves or there's churn? How do you make sure that there is a smooth transition from your old roles and authorization to the new one? That becomes super important. And depending on your particular configuration, you also want to have fully configurable deploys. So this includes your A/B testing. This includes your canary deploys, ways to make sure that your rollouts are safe and you can do them reliably. So those are things to be aware of when you're building in the open source. By our best estimate, if you want to build out a robust MLOps platform, it's going to take you at least, let's call it 5 super strong developers, and they're spending a year and a half to 2 years. You can hack together a thing very, very quickly, which is what the previous blog post talks about. But if you want to actually run these systems at scale and have them serve your customers, it actually requires a lot more work. So in the last 5 minutes, I'm going to give you a snapshot of what a enterprise MLOps platform looks like. And I'm gonna walk through some screens on Verta to give you a taste of what this can be. I know that lots of people here may not be in an enterprise that might require very robust requirements around MLOps, but I'll just walk you through it. Okay, so what do you get with an MLOps platform? So we start here. So we start off with a creation phase where you start versioning and managing your models as you are building them. Then we'll go to the packaging phase where we stage models for production. Then we'll go to the deployment phase, and we will wrap up with a monitoring phase. And you'll see what a MLOps system should look like as you're either building it or looking at options for what to use. So this is a quick snapshot of the overview page that we have that's more geared towards managers and your executives that might be on your team. If you're a data scientist, you're spending most of your time building models and looking at what we call experiment runs look like. This is heavily based on ModelDB, which was my work at MIT, and I'll show you what that looks like as well. So for a particular experiment and a project that you're working on, you're going to be looking at different experiment runs. These are quick views into what were the parameters that were used for this run. So I have my notebook, I have my Python environment, I have the data sets that I used, a bunch of hyperparameters. You might have metrics, you might have artifacts, you might also have images that you have registered. In this case, I have data sets that are S3 data sets, and I version them because I want to be able to reproduce the whole model from scratch. So there is a lot of rich metadata that you store or should be storing during your experiment management phase of your model lifecycle. And what this allows you to do, going back here, is it allows you to compare different experiment runs to see what has changed. And this becomes very crucial once you find a production issue and you're like, what did I change that actually caused me to see better or worse outcomes in my model? So this is quickly what a experiment management phase would look like. Until now, we're just in the creation. Next, I'm going to walk to the staging phase because, as you would probably know, when you are building models, you build thousands of them, but you don't put all of them into production. What you do put into production is the best, and that's typically 3 or 4 models that you're going to iterate on. So that's where a model registry comes in, and I'm giving a technical talk on model registry on Thursday, so feel free to join then. We'll go into the details of what a model registry gets you, what do you need from a model registry, etc. So a model registry is a place where I put my best models here, and you will see that some of these models are in development, some of them are in production. This one is also in development. What a model registry lets you do is have very tight approval workflows. So if you're not ready to deploy a model, then you don't stage it to production. There's someone who's going to come in, make sure that your model is working as expected, and only then deploy it. So that's the model registry. Once you have registered the model, then you can package it in a variety of formats. I've set up this particular model to be packaged as a Docker container. You could also package it as a Spark UDF. You could package it as just a Python library, a host of different options. But that's the packaging piece for you. So at this point, going back to the diagram, we have staged and packaged. Now we'll go off and release and configure to see what that looks like. If you have the system set up correctly, it's going to capture the environment for you. It's going to capture all the pickle files that you need in order to deploy a model, and then you should be able to just hit a deploy button and then get an endpoint. I'm going to use a pre-configured endpoint because Docker containers can take a little while to build. Here I have pre-configured an endpoint, which is this moccasin squid thing. When I go here, the endpoint is the API that you can hit in order to use the model. And there are several details in here that I won't get into, but once you have an endpoint, then you can make calls against the endpoint via any type of either Python function, REST. It's essentially a REST API. So here I'm sending it some data, I'm getting data back. And for a system that is set up correctly, you can start seeing monitoring information for it right off the bat. So you'll see here that I see the latency, I can see the throughput. If you've also registered the data that's going in and out of it, you're going to be also able to do data drift detection and things like that on top of it. The final piece I'll show here actually, if you have your data configured appropriately, then you're also going to get monitoring, as I was saying, on one of these charts. The final piece I want to highlight here has to do with more of the operations. So when you are deploying a software model, you have several builds that you work with. You want to also do updates or rollouts of your services. In that case, what we found is it's super important to be able to set auto scaling thresholds. Like, how do you want your model to scale? What are the resources you need? Do you need GPUs? Do you need CPUs, memory, all of that? And giving the user the ability to do a canary rollout, to do A/B rollout, all of that. So as you're thinking about how often you need to update your model, how do I safely transition my customers from one version or the other? A very flexible update strategy becomes important. And the last point I'll highlight here is a lot of times you don't need to change the way that you're doing ML in order to use an MLOps system. You should be able to just, in our case, import a library into your Jupyter environment, and then you should be able to make API calls and be on your way. So whether it's your log model, log requirements call, it could be register my model version, it could be, just get my deployed model and start making predictions around it. So the flexibility of integrating these models into your application is super important and something for you to think about. So what we've done very briefly right now is gone through the creation, which was experiment management, to registry, which is staging, to deployment, to monitoring. And as you see issues, they're closing the loop as well. Since we're getting to time, let me just wrap up and then take any questions that folks might have. In summary, at this point, building models has become pretty easy. Building intelligent products is still hard. MLOps as a discipline helps you build and ship ML products rapidly. If you're a small ML shop, open source is going to get you pretty far, and that's where I usually recommend people try that out. If you hit hurdles, then it typically warrants for a more robust solution. If you need production support, check out vendor solutions. At Verta, we do this all day, so happy to take questions around that. That's it. Happy to take questions. I'm giving the talk Thursday on model registry and that particular piece. Do feel free to join there. And you can look me up on Twitter, my email, and that's our team Slack channel.